Okay, so here are the notes for solving quadratic equations by square roots. So first off, we're going to talk about the radical right here. So the first thing we're talking about is inside of this radical, whatever term is inside of here, it's called the radicand. This symbol you're looking at is called the radical, and that is sometimes we usually refer to that as the square root just because there's no number in here. And the small number that's inside of this hook is called the index. So right now there is no number in there, so we assume it to be a 2, and that's why we usually call this the square root. All right, on top of this, we have two properties that help us to simplify radicals. The first one, the product property of square roots. If a and b are positive, then the square root of inside a times b is equal to the square root of a times the square root of b. So notice we just split it apart. So an example of where you might use this is if you had like the square root of 12. And we could split this apart into two factors, the square root of 4 times the square root of 3. And the reason why we would do this because the square root of 4 we know that reduces to 2 times the square root of 3, and that's why we use that property. We also use this property sometimes to go backwards. So if we had like the square root of 2 times the square root of 3, we could multiply them together and get the square root of 6. The second property we have is the quotient property of square roots. So if a and b are positive, we have the square root of a divided by b. And this can actually be broken apart into the square root of a divided by the square root of b. And notice I had that b cannot equal 0, and because if not, it would be undefined at that point. So you can split them apart if you like. So an example of this would be like if you had like the square root of 81 over, let me see, 16, right? So right now it's just the square root of 81 over 16, but we could break this apart into the square root of 81 divided by the square root of 16, and hopefully we see that the square root of 81 is actually 9, and the square root of 16 is actually 4. So our answer would be 9/4. So that's when we would use that property. All right, so let's try some examples here. So for this here, it says to simplify these radicals. That's what the directions pretty much mean here. So here's how I kind of do it. So you may use something called a factor tree. What I do is something very similar, but I just keep my factors in order. So the first thing I do is I take the 80 and I write it. And then I do an upside down division bar or division sign, right? So the division sign upside down like that, okay? And then I look for a prime factor that fits into 80. And preferably I want it to be as small as possible, that way so it gets easy, right? So the smallest prime number that goes into 80 is 2. And if you've forgotten, a prime number is divisible by 1 in itself. So 2 is a prime number. Now 2 goes into 80 40 times. All right. Now from there, I look for the smallest prime factor that goes into 40. In this case, again, it is 2. 2 goes into 40 20 times. And then I keep following that process until I get to the number 1. So we know that 2 goes into 20 10 times, 2 goes into 10 5 times, and 5 goes into itself once. So at this very last point, I know that this is my final factor because 1 is always divisible by itself. So 1 would be continuous, but we stop right there. Okay, so now what we're going to look for is pairs. And the reason why we're looking for pairs is because this is a square root symbol. So we're looking for groups of 2. So I'm going to see how many groups of 2 I have, or how many pairs I have, not a group. So my first pair is a pair of 2s. That's one of them. Then I notice I have another pair. So I have 1, 2 pairs of 2. All right, so now I start with my radical sign. So if it is a pair, it's going to go on the outside as 1, right? So I have 1 pair of 2s. That's going to go on the outside. And then I have another pair of 2s. That's also going to go on the outside. Now, what I did not circle are the ones that are not pairs. So I didn't circle a 5 and a 1. What we're going to do is we're going to take 5 times 1, and we're going to put it back in here. So I'm going to show you the work, 5 times 1. Then I'm going to simplify, right? 2 times 2 is 4, and 5 times 1 is 5. So we have 4. Radical 5 is our simplified answer for the square root of 80. Let's take a look at the next one. So we have the square root of 6 times the square root of 2. So it's using this property right here, like the square root of 6 times the square root of 2. So we're going to put them together by multiplying it. So they have the same radical, the square root, square root. So we're going to do, and I'm just showing you the work, the square root of 6 times 2, which is the square root of 12. Now, once we get to this square root of 12, we're going to try to simplify that. So again, I'm going to do the upside down division. So 12. And we're going to try to find the smallest prime number that goes into 12, which is going to be 2. 2 goes into 12 6 times. Smallest prime number that goes into 6 is 2 as well. 2 goes into 6 3 times. And last, 3 goes into itself 1. So once again, we stop when there's a 1. We're going to draw a radical sign, and we're looking for pairs again. So again, I see a pair of 2's, and my pair comes on the outside as 1. And whatever I didn't circle, I'm going to underline. I'm going to multiply that together. 3 times 1 is 3, and it goes back inside the radical. So my answer here is 2 radical 3. All right, and let's look at this last one here. We have the square root of 24. So again, we're going to see if we can simplify it. So upside down division bar. The smallest prime number that goes into 24 is 2. 2 goes into 24 12 times. Again, we divide it. 2 goes into 12 6 times. 2 goes into 6 3 times. 3 goes into itself once. So draw my radical sign. The pairs that I have one pair of 2's that goes on the outside, and I have no other pairs. So what I did not circle that does not have a pair is 2, 3, and 1. So 2 times 3 is 6. 6 times 1 is 6. So we have 2 radical 6 as our simplified form of that radical. All right, for this next one here, we're going to use the quotient property. So we have the square root of a divided by b, and we're going to break that into the square root of a divided by the square root of b. All right, so for this first one here, I'm going to break this apart. So instead of the square root of 4 over 81, I'm going to change it to the square root of 4 divided by the square root of 81. So now I can see that the square root of 4 is 2, and the square root of 81 is 9. So my answer is 2 ninths. All right, and for this last one on the front page, again, we're going to use that quotient property of square roots. So we're going to break it apart. We're going to separate it. The square root of 7 divided by the square root of 16. Square root of 7, we don't know what that is, and 7 is a prime number, so it cannot simplify beyond that. And the square root of 16 is 4, and I can't go any further, so this is my final answer. Okay, let's continue. So rationalizing the denominator. So we're going to rewrite a fraction so that there are no square roots in the denominator. So we do not want a square root in the denominator. Okay. The way we're going to do this is by using the conjugate, and I'll show you what the conjugate is. Okay. So our first thing we want to do is we're going to start with this problem. We have the square root of 5 divided by 2. So we're going to separate that into the square root of 5 divided by the square root of 2 by using the quotient property. Now, as you can tell, we have the square root of 2 in the denominator. The square root of 5 on the top doesn't matter. It's really focused on this. We cannot have a radical in the denominator. So how do we remove that? Well, it's pretty easy. When it's just a single radical in the denominator, just by itself, like the square root of 2 is by itself, we just multiply by that radical. So we will take that radical 2 and we multiply it to the numerator and the denominator, so the top and the bottom of the fraction. All right, from here we multiply it. And since these are both underneath the square root, and they both have the 2 there, so the square root of 5, square root of 2, we can multiply. The square root of 5 times the square root of 2 is going to be the square root of 10. So notice the 5 and the 2 are inside the radical, so when I multiply it, it goes back inside the radical. If there was any numbers on the outside, I can multiply those together, and it would go on the outside. So multiply outside with outside, and put it on the outside. Multiply inside with inside, and put it in the inside. Now on the bottom, we have the square root of 2 times the square root of 2, which is the square root of 4. And hopefully you recall that the square root of 4 reduces to 2. Now at this point here, you may be thinking you want to divide the 2 into the 10, but you cannot do that because this is not 10, this is the square root of 10. which is not the same thing as the actual number 10. The square root of 10 is like 3 point something. You can type that into a calculator and see. So 2 does not go into that 10 evenly. This would be our final answer. All right, now that's pretty easy. So when we have just a radical on the bottom, we multiply the numerator and denominator by that, and that's how we get rid of that radical. Now it does change when we have a number be either being added or subtracted to the radical, or the radical being added or subtracted to a number. So in this case, if you look at the second problem, we have 3 divided by 7 plus the square root of 2. So the first thing you'll notice is that we do have a radical in the denominator, but it's not like the other one where we just multiply by radical 2. This time, we're going to multiply by the conjugate. So let's kind of talk about what the conjugate is. So I'm just going to give you a couple of examples real quick. So in the denominator, if you had 2 plus the square root of 3, okay, the conjugate would be 2 minus the square root of 3, okay? I'll give you one more example. If we had 5 minus the square root of 7, then the conjugate would be 5 plus the square root of 7. So hopefully you see the pattern that whatever the sign is in the middle, the conjugate is just the opposite sign. That's it. Nothing else changes. So 5 minus the square root of 7 becomes 5 plus the square root of 7. And what that does is when you FOIL it out, which is what we're going to do, you'll notice that the two middle terms cancel, and then when we simplify it, there is no radical in the denominator. If there's a radical in the numerator, that's fine. We're just mainly focused on the denominator. All right, so if you look at this one right here, in the denominator, we have 7 plus the square root of 2. So the conjugate would be 7 minus the square root of 2. And just like before, we multiply that to the top and the bottom. All right, so let's talk about how to FOIL this out. So on the top, we're going to distribute. 3 times 7 is 21. 3 times negative square root of 2. So notice this 3 is not inside a radical. So we multiply it and put it in the front. So it becomes negative 1 times 3, which is negative 3. Square root of 2 because we have nothing else. Now on the bottom, we're going to FOIL it out. So we have 7 times 7, which is 49. Then we have 7 times negative square root of 2, which is negative 7 square root of 2. Square root of 2 times 7 is positive 7 square root of 2. And the square root of 2 times negative square root of 2 is negative square root of 4. Now, as you're looking at this, hopefully you see that the two middle terms, when you multiply it out, do cancel. Negative 7 square root of 2 plus 7 square root of 2 equal to 0. And then we're going to rewrite the top, 21 minus 3, radical 2. We cannot take away the 3 from the 21 because the 3 is connected to the radical 2. They're being multiplied. And on the bottom, we have 49. Then we have a minus sign right there. And the square root of 4 is 2. Now, at this point, hopefully you see there is no radical in the denominator, and we know we're on the right track now. And the last thing we do, we simplify it. So 21 minus 3, radical 2. Over 49 minus 2, which is 47. Now, to make sure we are done simplifying, we look at 3 numbers. We look at the number right here, which is 21. We look at the number right here in front of the radical, which is 3. If there was no number in front of the radical, it would be assumed to be a 1. And then we look at the denominator number, which is 47. So 21, 3, and 47, they do not have a common factor. So you cannot reduce it. And this would be your final answer. All right, and now we're down to this last one right here. We have 4 plus the square root of 3 divided by 1 minus the square root of 6. Now with this one here, again, we want to find the conjugate. Notice there's 2 radicals, one in the top, one in the bottom, but we're only focused on the denominator. So our conjugate comes from the denominator here. So if this says 1 minus the square root of 6, the conjugate will be 1 plus the square root of 6. All right, and just like before, we're going to FOIL this out. So for this one here, on the top, we have 4 times 1, which is 4. 4 times the square root of 6, which is 4 square root of 6. The square root of 3 times 1 is plus 1 square root of 3. And the square root of 3 times the square root of 6 is the square root of 18. All right, now we're going to simplify the bottom. 1 times 1 is 1. 1 times the square root of 6 is positive square root of 6. negative square root of 6 times 1 is negative square root of 6. And negative square root of 6 times positive square root of 6 is negative square root of 36. All right. So now from here, we're going to continue to work and try to simplify things. So on the top, we're looking to combine like terms if we can. So we have 4 plus 4 square root of 6 plus radical 3 plus the square root of 18. So the first thing I notice is the square root of 18 right here. This can be simplified. So I'm going to simplify that up here. So we have the square root of 18, and we're going to flip that over and put the upside down division bar, and we're going to break it down. So the smallest prime number that goes into 18 is 2, 9 times. 3 goes into 9 3 times, and 3 goes into itself once. Now, we put our radical, and we're looking for pairs. So I see a pair of 3's, and I did not circle the 2 or the 1, so 2 times 1 is 2. That goes back in the radical. All right, so what happened here was that it now became 4 plus 4 square root of 6 plus the square root of 3 plus, and this becomes 3 radical 2, the square root of 18. All right, and now when I look at the top, I can't actually combine any of them because none of them are like terms. All right, now on the bottom, we have 1, and then we have plus the square root of 6 and minus the square root of 6, which means they cancel out, minus, and the square root of 36 is 6. So I can actually simplify this by subtracting. So we have 4 plus 4 square root of 6 plus the square root of 3 plus 3 square root of 2 over negative 5. All right, now some people will put this negative up top and make everything opposite sides. So negative 4 square root of 6, negative square root of 3, negative 3 square root of 2. But this answer is acceptable. But in case you are curious, it would actually become negative 4 minus 4 square root of 6 minus the square root of 3 minus 3 square root of 2 all over 5, if you decided to do it this way. But both answers would be correct. All right, so we're down to the last parts here. It says solving equations of the form x squared equals a, so there is no b value. There can be a c value, just no bx, okay? So right here, x squared equals a. So first off, it says a must be positive. So this number right here has to be a positive number. Next, you're going to take the square root of both sides, so the square root here and the square root here. Now, when you take the square root, you will have two solutions. So the first thing you're going to notice is you have a plus or minus, right? Because in a quadratic function, for the most part with these types, they're going to cross the x-axis twice. So we have plus or minus the square root of a, or we can write that as x equals the square root of a, which is positive, and x equals negative square root of a, which is obviously negative. So now we have two answers, which can be written as plus or minus the square root of a. Okay. All right, let's go ahead and see how we can apply this. So we have three problems we're going to solve by using square roots. So whenever I'm solving these, I pretty much do PEMDAS backwards. So notice that's PEMDAS backwards. So I usually add or subtract first. So I identify where my x squared value is, and I look to see on the outside of it, are there any addition or subtraction? Well, I see minus 7. So to undo that, we just do the inverse operation, which is add 7. And then we come up with x squared is equal to 36. We don't have any multiplication or division because there's no number in front being multiplied. But we do have an exponent. We have a square. And to undo the square, you take the square root. When you do take the square root, you need to put plus or minus immediately, right? If you look back on your notes from the other part, it said you would have plus or minus the square root of a. In this case, we have plus or minus the square root of 36. So from this point here, the square root and the square are inverses, so they cancel each other out. And then we have plus or minus, and hopefully you know that the square root of 36 is 6. All right, let's take a look at the next one. So again, we are going to try to solve for x. So the first thing we do is add or subtract. So I see a positive 5. To undo that, we subtract 5 from both sides. And that's going to give us 3x squared. The 5's cancel. 41 minus 5 is 36. Now we're going to look for multiplication or division, which we do have 3 times x squared. So we're going to do that by dividing by 3. So 3x squared divided by 3 is x squared. 36 divided by 3 is 12. Then to get rid of the exponent, we take the square root. Don't forget your plus or minus. So the square root of x squared is x equals plus or minus the square root of 12. But 12, we're going to attempt to simplify that. So we would take 12 upside down. 2 is the smallest part number that goes into 12 6 times. 2 goes into 6 3 times. And 3 goes into 3 once. So right here I have a pair of 2's. So x equals plus or minus. I have a pair of 2's that will come on the outside. And I have 3 times 1 that will go back in the radical. So 3 times 1 is 3. And so my final answer is x equals plus or minus 2 radical 3. All right, and we're down to the last problem of these notes here. So we have 3 times x minus 2 squared is equal to 24. So for this one here, we first look for addition or subtraction, which there's nothing on the outside like that, right? So now we look for multiplication or division. This says 3 times x minus 2 squared, so we would undo this by dividing both sides by 3, which gives me x minus 2 squared equals 24 divided by 3 is 8. Now from here, we're looking for division, multiplication. Oh, sorry, we just did it. Sorry, exponent. So we have an exponent of 2, so we take the square root to remove that. And don't forget to put plus or minus. So again, the square root and the square are going to cancel each other out, leaving us with the inside of x minus 2. And plus or minus the square root of 8. So we're going to take the square root of 8, and we're going to break that down right up here. So we have the square root of 8. And we're going to start with division 8. 2 goes into 8 4 times. 2 goes into 4 twice. And then 2 goes into itself 1 time. So now we're going to circle pairs. So I have a pair of 2's. And that's it. So 2 square root of, and we have 2 times 1, which is 2. All right, last step, we have to isolate the x. So we're going to go ahead and add the 2 to the other side. And be careful here. You can't actually add this 2 to that 2 because the second 2 right here is connected to radical 2, like 2 times radical 2 and so on. So in this case, we have 2 plus or minus 2 radical 2, and I'm going to put this in the front. And this is your answer. All right, and that concludes the notes.